Welcome to another episode of Build Day TV. I'm Alistair Cook, and we are carrying on with episode 4 of our series on the VMware SD-WAN solution. In this episode, we're going to learn about application performance and see how to configure it. And of course, joining me is our subject matter expert for VMware's SD-WAN solution. Hey Rohan, Mr. Rohan Nagani, how are you today?
Hey Alistair, I'm doing good. Back to this application performance, which is VMware SD-WAN DMPO, what we call it as Dynamic MultiPath Optimization. So before we get on to the hands-on, let's understand what we are going to do out here. DMPO with DMPO, where once the edge device gets activated on day one, they build up SD-WAN overlay tunnels to gateway, hub sites when the hub sites come online. Once the data path is ready, then the underlying WAN link condition keeps changing. You can have a blackout or a brownout condition. So how to protect against those? If I have a high priority application, right now we are doing a Zoom call, which is a high priority application. It should not get affected if I just go and pull out one cable. When I say cable here, I mean the ISP link from my edge device. Our audio and video session should be intact. And that's what this whole session or this episode is all about.
So in the previous episode, we looked at standing up the initial connection between the various edge devices and locations that you have through the cloud gateway or through hub devices. And this session is really about making sure that you're getting good performance on an ongoing basis with the collection of applications that you're running.
Correct. So for that, the edge device should be intelligent enough to recognize the application, because there are, business policy framework where you can define which application is high priority, low priority. But before that, you should be able to recognize the application. You should be able to know what applications you're seeing on your network. And that's where this DPI engine, deep application recognition, comes to play. And then the second thing here is, how should I leverage all the circuits? How can I get that application SLA, which can be guaranteed by a service provider on a private MPLS circuit? Can I get that on a public circuit? And the answer is yes, using this DMPO. That's where that secure overlay also comes to play, because enterprise should be able to send their enterprise traffic on a public internet in a secure way. And that's where that cloud VPN comes to play. And now, when they can leverage both the circuits, what about the link quality? How many paths do I have? How are each path performing? On which path I can take my application, which is a high priority application. So all those things are part of this dynamic multipath optimization. And then there are times when some of the branches might have a single internet link. So how do I do some on-demand remediation on a single internet link, or maybe on a hybrid WAN? That's where this on-demand remediation comes to play. So if you ask me, DMPO in kind of a summarized way, it is all about continuous monitoring. We are monitoring all the circuits, and then in a dynamic fashion, we are doing per packet steering. Remember this, per packet in a sub-second fashion. We break the flow into small packets, and we leverage all the circuits out there. And that's where that multipath comes to play. We leverage all the circuits, all the tunnels in a per packet fashion. And then in sub-second fashion, we steer application traffic when there is any underlying link condition changes. And then application quality of service, QoS, is already there. It should not happen that the low priority application should take over when there is a high priority application. So all those things is what we call it, the feature as DMPO, Dynamic Multipath Optimization.
So with that, we'll head into the first task where we look at that stage where we're identifying the applications. That's the fingerprinting piece here.
Yes, it's very important to recognize the application by the edge device. Otherwise, those rules cannot be applied here. And for that, we can use Office 365 or the Zoom call. So let's go back to our orchestrator out here. And you can see on the monitor tab of the orchestrator, you will get all the statistics out there, whether it's related to the link, application, or the endpoints out here. So this is my home edge device. I'm going to click on that home device. For past 12 hours, you can see the link statistics over here. I can click on this right arrow and I can get all those WAN performance metrics which can affect any application traffic. So you can see here for service provider 1 here, out here, I can see 17 millisecond upload latency out here. I can see all the applications which are getting recognized. So we are on a Zoom call. You can see the Zoom call out here, Office 365. So these are the top applications which we are seeing out here, and then they are categorized as a business collaboration or file sharing. If I want more information out there, I can drill in, and let's say for past 7 days, we can check how many applications this device, edge device, has recognized. So this edge device has recognized around 273 different applications like these business critical applications like Zoom or Office 365 application. You want more details, you can click on that and it will give you more details out here. So that's the first fingerprinting which comes to play. Now so that we are having
automated fingerprinting, isn't it? That's not something you've had to go through and categorize and say this port or this DNS name here. You don't have to do that. This is all automated out here. But at the same time, you asked me a good question out here, is that as a customer, if I have a custom application, then I need to go and define that custom application. Once that custom application is defined based on 5 tuples, then you can, once you send application on that, using that custom application, let's say on a destination port or destination IP, then this device using the API engine will show that application name out there. So it will show out. So let's go to our packet capture, kind of a remote diagnostic tool, and let's check what's the active flow looks like when we are going to run this fingerprinting out there. So let's see at this moment what all applications are getting recognized from this laptop. So you can see here I have PowerPoint, on here. Office 365 is on. You can see here I can log in out here to Office 365. Our Zoom call is on, and all those traffic you can kind of see it out here. So for Zoom traffic, which is a real-time business collaboration application, it is going through the gateway. It is not going directly to the internet. If I open a Netflix application, just to give you a use case out here, then you will see it's going directly to the internet. So there are smart defaults already in, but what we have kind of defined out here is that the fingerprinting is kind of working out. You don't have to go and define for each application. So with that, let's move on to the task number 2, Alistair, if we are ready for that. And we will check out on the real-time and the recreational application. Yeah, it didn't look like your family was on that same network link, because there wasn't nearly enough video streaming going on, if it's anything like my family.
So what I want to show is this is a recreational traffic, which is smart default, which is already defined on the business policy framework. Let me first showcase you that before we check the end result out here. So let me go to the configure, let me go to profile, or you can do it override from the edge device also. So there are smart defaults defined in, which means you don't have to go back and for each application type to define rules. So you can see here for box, we say that it will use the VMware SD-WAN, which is multipath, which can use any path or all the paths it will use. And it is considered as a bulk application out here. For Netflix, it will be considered as a direct application where it is either a social or a recreational traffic. Let's check that out here. So I can go to application out here. I can type in Netflix, and you can see here it belongs to the media out here. So by default, Netflix traffic is supposed to go direct. So it will skip the gateway. It will not get optimized using VMware SD-WAN DMPO. That's what this use case is all about. So we will use a real-time application, which is a Zoom application, and a recreational application, which is a Netflix application. So I'm going to start off, let's say, kind of a Netflix application out here. Let me pause this out here. Zoom application is also going in. And now if I go to the edge device out here, and if I go to remote diagnostics, we should see in an active flow Zoom and Netflix traffic. So let's go out here, list active flows. I'm going to run out here. I could also give out, I can sort it with my laptop IP, which is 192.168.20.22, I believe. Let me double check it. CMD IP config. Yes, it is 20.22. You can see out here. And now all the traffic which is getting initiated from my laptop, it will show out here. So Zoom traffic, which is we are right now talking, it is going through the gateway. You can see here Netflix traffic. It is getting load balanced because I have two links. It can load balance between both the links, but it is going directly to the cloud from my laptop to the edge. That's where this smart default comes to play. So I haven't created any business policy.
What was the replicate configuration that was on Zoom? You had load balance on Netflix, but on Zoom you had replicate?
Yeah, so replicate here means, if you remember with VMware SD-WAN DMPO, we break the session into per packet, if you remember, and those packets, Zoom packets, packet 1, packet 2, packet 3 might go from link 1. The other packets from the same session can go to other links. And then on the other end, on the gateway, we can reorder it, because whenever we are sending these packets, we are tagging it. There is a timestamp attached to it. There is a packet number there. That tagging is there. So that's where you see that replication happening.
So is that the same network packet from Zoom is being sent through two paths to the gateway, or is it that a single packet just goes through one, but the next packet might go through the other?
So it can, based on the link conditions, it can, some packets can go through link 1, some packets can go to link 2. But if links start seeing some, let's say, latency or packet loss, then we can start duplicating packets also at the same time. So what it means is packet 2 can go through link 2 also and link 3 also. And whichever that packet number 2
gets to the gateway.
That can be picked up. So that's where we are leveraging both the circuits, both the links. And that's where this replication comes to play. And then this behavior, we don't do it for all the applications. Let's say if it's a transactional or bulk application, we are not replicating it. Based on the application type, the application that matters to that enterprise, real-time application, high priority application, for those applications only we are choosing this behavior. Let's say if it's a bulk application, the moment this edge device will see that it's a bulk application, I'm doing a box.com download, instead of replicate or load balancing, it will aggregate all the circuits and it will do a faster download. Makes sense? That's where that smart default comes to play.
So load balance is using a single one of your multiple connections at a time, but can shift between. Whereas the bulk will aggregate them together, and the replicate will provide the highest availability using those two links.
Yes. And now let's check on the high priority traffic that it is using the best available link out here based on those three parameters: latency, jitter, and packet loss. So if for our Zoom call, if I go to the live troubleshooting tool, again, I'm using that tool out here where we can go to live monitoring. Let me click on this show TCP UDP details. So for the Zoom session, let me click on the other. So for Zoom traffic, you can see it has picked up the preferred path, which is the Comcast cable, based on those three WAN impairments. Based on those three WAN performance metrics: latency, jitter, packet loss. So let's check what's happening on the other service provider, in this case, the Sail Internet. So let me go back here and let me check on that. Why it has picked up Comcast for Zoom. Maybe the latency, jitter, or packet loss might be higher on the other service provider. So the key here is that based on the application SLA, smart defaults comes to play, and it will select the best available path when you have multiple circuits out here. So let me go back to my home edge device out here. So I'll click on this, and then we'll put this into a live mode out here. And this is where you see, you can have the comparison here. Latency is around, you can see here, it's like 14 to 15 milliseconds versus there is a high latency on my other ISP link. And that's where that Zoom connection is right now going on this preferred link. If I trigger, or if there is a latency or a jitter or a packet loss increase happens on this Comcast link, which is higher than the SAIL internet, then immediately in sub-second fashion, the Zoom application traffic will move over to the other link out here. But for now, VMware SD-WAN DMPO thinks that this is the best available link for that real-time application traffic.
And I think one of the other things you and I were talking about before was the ability to separate out the path out of your network from the path back in, because I can see that one of your circuits has a 6 meg upload, whereas the other has a symmetric 100 meg link. And there could be a situation where the download is still really good, but the upload bandwidth has been saturated. It was the ability to separate those and send replies on a different path to the requests is interesting.
Yes, but for any application, these three parameters matters a lot. Even if I have a higher bandwidth, in this case, if you see, 100 up, 100 down approximately out here. But if I'm having latency jitter packet loss, higher packet loss on that link, then for most of the application type, it will use the other service provider.
Yeah, it only becomes important when you saturate that in particular upload bandwidth that seems to be not symmetric on that link.
Yes. And then we have seen if I have, let's say, Netflix traffic, or if I browse yahoo.com or any website which can be considered as a recreational traffic or direct internet access, this will skip the gateway. The packets will not go to the gateway for these application traffic, and you can monitor them through the those remote diagnostic tools, and you will find out that this traffic is not getting optimized using DMPO. There is no DMPO applied to traffic which is going outside of the SD-WAN overlay tunnel.
Okay.
Only traffic which goes inside the SD-WAN overlay tunnel, that's where this magic of DMPO comes to play. What magic? This link steering, on-demand remediation, continuous monitoring of the circuit. So you are well protected from the blackout or the brownout condition. And now you can go in advance. You can kind of hairpin that, hey, for compliance reason, I want my Zoom traffic to always go on, let's say, the service provider link out here. So let's say my link is my Comcast link in this case. I want my Zoom traffic to always go on this link. What it means is if this link goes down for some reason, you will not have link steering to the other link because you have kind of hairpinned the traffic. That is typically used in a PCI certification kind of a scenario where you are under some compliance, enterprise is under some compliance. There is a second option which you can kind of select is the preferred option. In that, you are preferring this link A for, let's say, the Zoom traffic. But for some reason, if this link cannot maintain the SLA, then immediately in sub-second fashion, the link steering will happen and your application will move on to the other link. And when it is going on to the other link, like I mentioned, we are monitoring all the circuits, continuous monitoring is happening. This is back online. And now the application SLAs can be maintained. Then as this is a preferred link, we will be back to this link. The application.
So you'll bring it back up just because it's up and reliable. You'll move the traffic back again. Yeah.
Correct. And that's where that preferred option comes to play. So these are the advanced options there. And then we have the other available options out there also where it will move to the best available link out there. So these are the three different options, and we'll play around with, one of the options out here is the preferred option. So you can see here right now, Zoom traffic is going to one of the service provider link. But what I'm going to do is I'm going to override that behavior, and I'm going to say that always use this Comcast link in my case, case out here, where it will be the preferred link. So by default, the Zoom traffic will go on the Comcast link. But if we introduce, let's say, some kind of a brownout conditions on the Comcast link, let's say if I introduce 4% packet loss, we will see that in a sub-second fashion, then the Zoom traffic will be moved over to the other link out there. And that's what we are going to perform out here. So I'm going to override the default behavior. So let's log into the edge out here, and I'll go to the business policy framework.
So normally this is part of the policy that's applied to the edge, but you're making a manual change just on one edge.
Yes, if I want it on multiple edges, then I will apply it at the profile level. So I can go to app, and this is where that DPI engine comes to play. We can recognize this application, and this is high priority application, multipath. All the links will be used. Link steering is auto by default, but what we are trying to do out here is we are picking a preferred link. So I will select Comcast cable in this case as a preferred link. And then I can have this option also, error correct before you steer to other link, maybe you can have some threshold set out there. So you can do that also. So I'm going to unselect that for now, but I will select my preferred link as the Comcast link. So I'm overriding the behavior out here from the smart defaults. I'll save changes, like I mentioned previously, that it will take 30 seconds for this rule to get effective. Orchestrator will push the changes to the edge device. We'll go to events. Let's go to events.
And in the configuration, it was very explicit that there was a manual override on this edge appliance because it was in a separate group of rules. You could see what was set locally and what was being inherited from the policy. Is there a way to see from the policy side whether there are overrides applied on individual edge devices?
So one way to look at it is, let me show you. So if I go to monitor, configure edges out here. So let me show you. If I get the edge view out here, so you can see here on my home edge, it shows a blue icon out here for the business policy. So this tells me that there is an override happening
a local configuration
at the edge level. And then this is kind of a shortcut. Instead of me going to configure edges, click on my home edge, then click on the business policy framework, I can directly click on here. And that's kind of a shortcut which you have generally on your desktop. You can directly go to the business policy under the home edge. So we'll go back to the live troubleshooting tool, and we will check on the Zoom traffic as a next step to validate it. I'll go click on the transport tab. We will enable the live troubleshooting. But before that, make sure that the 30 seconds are over so that the policy gets pushed over. So live troubleshooting is enabled out there. I'm going to uncheck all these, and you can see your Zoom traffic, which will be going on through the preferred link. And at the same time, what I'm going to do is I will show you the active flows, those active flows for this home edge device that the Zoom traffic is going through this edge device. So let's see, you can see here, the preferred link here is the Comcast cable in this case. Now, if I introduce any conditions, those WAN performance conditions out here, and if it doesn't maintain the application SLA, then it should immediately, in sub-second fashion, our Zoom traffic should fail over to the other service provider link. So let's check the WAN parameters before we do that switch. So let me go back here, stay in live mode, and you can see here we have latency on the other link. We have around 2% packet loss. There is no packet loss on the Comcast link. So what I'm going to do here is I'm going to introduce 4% packet loss on this Comcast cable. After that happens, our Zoom connection should be intact, audio and video, and at the same time, in sub-second fashion, it should steer that Zoom application traffic to the other link for this real-time application. That is what we are going to perform out here with the WAN impairment tool. So I'm going to introduce kind of a 4% packet loss upload and 4% packet loss in both the directions. So 4.4, which will be 8% packet loss on the Comcast link. So I think that takes some time for that tool to apply the packet loss. You can see here.
I can see the change already.
In sub-second fashion. How is my audio and video? Is the video clear, the audio clear in this case?
Yeah, you're still coming through good. And it's interesting to see that the bandwidth has stayed the same on the Comcast cable. The impaired link is still sending the packet. So we are in that sort of duplication of traffic to give us the highest probability of actually getting the packets through.
And we will see, it will do the measurement and it will show the real packet loss out here. Remember, 4% upload and 4 download. It will show out here in the live mode. But the key here is that in sub-second fashion, we have seen that link steering happen for that Zoom traffic. Our preferred link was Comcast cable, if you remember. Now, as this is preferred link, the moment I remove out that packet loss, which was there introduced on the Comcast cable, we will see that our Zoom traffic is back on track out here to the preferred link. So you can see here, packet loss is kind of increasing out here on our preferred link.
Could that be because you have two pretty strong internet connections? If one of those, let's say the sale internet was 1/2 of or even less than of its speed, will we see the same type of results, or we see a slower regeneration?
So we will see similar type of results based on, again, these three WAN impairments, this WAN performance plus the bandwidth. It's not just about that you have big bandwidth, but then, you have choppy links. So when DMPO has to work, it will look into all these 4 key parameters out there. I think we are closer to that 5%. Now I can go back and change it to kind of 0. And as Comcast is the preferred link out here, when that WAN measurement happens and when this percentage loss is less than the sale internet out here, less than 2%, we will see that switch happening back to the Comcast link for this Zoom traffic.
Something's a little bit up with the traffic monitoring there, since it seems to have dropped to nothing for your received traffic, but you're still hearing us.
Yes, and if you remember, when we moved out to this link also had some brownout conditions. When I say brownout, means there was some latency, jitter, packet loss. Even on that link, DMPO was protecting with those on-demand remediation by doing packet duplication or forward error corrections. So we'll just wait for this to happen, but at the same time, you will see that it will come back to the preferred link once it knows that the Comcast cable in this case can maintain that application SLA. There is one more screen I really want to show is the quality of experience out here. So whatever we are seeing here, the blackout condition or the brownout condition, you can check out the score out here. So you can see here, you remember during the Cloud VPN episode, we pulled out the cable on the Comcast. That's where the blackout condition happened. So you can see here at this time, there is a blackout condition on the Comcast and your traffic got steered to the sale internet at that point. That was the point when we did the blackout condition test. So now, if you see here, we introduced packet loss at this moment. When we introduced the packet loss, it was monitoring both the circuits. And that's where that sub-second fashion, the Zoom traffic moved on to the other link because the other link could maintain that application SLA. And whatever link condition was there for that sale internet, like say 26 millisecond, there is a latency out there. It was able to correct it at the same time using the forward error correction or jitter buffering, or
So
what we call it as the on-demand remediation.
It aggregated two unreliable connections to get a slightly more reliable net connection.
And yes, and at the end of the day, it shows you kind of a before and after quality score. This after quality score is what is DMPO, what we call it as dynamic multipath optimization. So you can see here, there is an interval, like 310 to 320, which is kind of a 10-minute interval. So you can drag here and, you can move the mouse cursor and it can go back to that 5-minute or 10-minute interval. You can do a microscopic view and you can get that information for the link out there.
Okay.
So let me go back here. I think it just moved out of that live mode. But what we should see out here is that our Zoom traffic will get the, I think it's timing out for me. I need to change the timeout. That's because of the security reasons for the orchestrator, that if there is no activity, then it will log out the user. And that's where you see I'm logging on kind of multiple times out there.
Speaking of security, I have to wonder if we're talking enterprise for a financial security group, a Wall Street, or a government agency or something like that, where traffic has to be monitored and accounted for in every step. Is this the same types of systems that they would use for that, or would there be more security that the SD-WAN could offer on that?
This is the more security, because you can have multiple users, you can have users at different levels. So for those firms, like financial firms you talked about, I can create multiple roles. So for me, let's say if I'm a user, I'm a customer support engineer, and I just want to have monitor access. You want to give monitor access to customer support engineer. Then the only information, when you log in using your user account, you will have only access to the monitor tab where you can check out information, but you cannot do any configuration changes. But at the same time, if you log in as an enterprise admin, like what I'm logged in as right now, a super user, which is an enterprise admin, I can do configuration changes also. So based on your privilege, read-only, read-write access can be given out.
Yeah, I was thinking more on the fact of where the data travels through from Internet A and Internet B, which of course you can do at the home base. But if let's say you had to travel, we had to have some data go through my edge, and my internet, is just standard home cable and home phone. Is there any type of protocol in place or anything like that so that doesn't travel through a less secure area?
So remember, between my edge and your home edge, if we have a cloud VPN enabled, let's say branch to branch, all that traffic, whatever we define, let's say we define that the Zoom traffic or some custom application needs to go over the SD-WAN overlay, then it is already secured with the VMware SD-WAN solution. So end-to-end, wherever the tunnel SD-WAN overlay tunnel terminates from my side to your side of the home, then our traffic is secured. So we have seen the quality of experience. Let me go and check on the preferred traffic for the Zoom out here. I'll do the live monitoring out here, and we should see that the UDP traffic, in this case, the Zoom traffic, should be back onto our preferred link out here. And you can see that here. So it is back from the other service provider to my preferred link, which is the Comcast cable link out there. So that was the use case out here. And now let's perform blackout condition. So we have seen the brownout condition here for the real-time traffic. Next is the blackout condition, where we are having a conversation over Zoom. I'm going to go and pull out the cable which will trigger a blackout condition on the Comcast link. And then without any interruption, our Zoom call will be on. And in sub-second fashion, the Zoom traffic will move on to the next available link. In this case, would be the sale internet link out there. So let's quickly perform that traffic while this live monitoring is on. So let me go back, pull out the cable. You will see this turning to red. Immediately move over to the sale internet. Okay.
Unpull the cable. So Rohan is going to behave like a digger driver with a backhoe who cuts out the cable, whereas previously he was behaving more like some water being dripped into the cable and causing some packet loss along the way. So now that the digger is cut through, we can see the traffic has switched across to the secondary internet connection. And Rohan is all thumbs up.
I just wanted to
I was just saying, you're all thumbs up. The traffic has switched across. Everything continues to operate.
And how's my video? How's my audio quality? It's all intact. It's all moved to the sale internet. At this point, if the sale internet is having any latency, jitter, packet loss, DMPO is again in action, working behind the scene to correct. And we can go back in the quality of experience, the quality of score screen, and we can check that the Comcast link is kind of in a blackout condition and the link steering has happened. So let's say if 8 a.m. you are having a morning call and a lot of users complain that, hey, we are having a choppy audio call, you can come back to the quality of score screen and you can check what exactly is happening instead of calling the service provider or calling here and there and opening up tickets out there. So,
well, hopefully you have a secondary network and the service doesn't go down and you're seeing your alerts in here rather than hearing from your end users.
So I think within a minute you will see, quality of score. You will see that a condition like this where it's a gray screen where it shows that the blackout condition has happened out here. Again, remember our Comcast link in this scenario is a preferred link. What it means is the moment I turn on the Comcast cable, our Zoom traffic will be back onto Comcast. And that's what I'm going to go and check out. I'm going to plug back in the Comcast cable, and in sub-second fashion, that behavior should work out.
So faster than usual, getting a cable jointer to come out and fix where the backhoe has cut through. Rohan is going to reconnect the cables and we'll see the graph switch back, and we should see that traffic turn back onto the right-hand graph for the Comcast cable. Of course, I imagine there'll be a moment or three as the system identifies that it's a good network connection that's up rather than just a link light. And we see ourselves a live Rohan again, so the connection must be still working well.
Yeah, so we can see here the link is up and running on the Comcast as it's a preferred link. Zoom traffic is back onto the preferred link out here. So let's see if there is a quality of service experience we can see here. So you can see here during this time, which is 1420, this is where there was no information related to latency, jitter, packet loss because the Comcast link was that time having blackout condition. The service provider ISP, the cable was pulled out by the end user, and that's where it triggered a blackout condition. And in that scenario, your traffic was moved on to the other link, but even the other link had some fair amount of latency, which was taken care by DMPO, which is dynamic multipath optimization out there. The last test case here out is the smart defaults working for a bulk application. So if you're doing a download or a speed test, that's considered as a bulk traffic as per the smart default. And in that scenario, you will see that both the links are being leveraged so that you can have a faster download. So if I'm doing a speed test and if I go to the live troubleshooting out there, it will leverage both the links out there. Let me go back here when the speed test is going on. Let me put in
on the TCP for it.
Yeah, I'll put in TCP for it. And when the speed test is going, it will leverage both the circuit
See
out.
both, yeah.
Yeah. And you can see that out here. That
Now started.
and if I'm doing a box.com download in that case, then it will leverage both the circuits out there. And I can go back and I can do average throughput also. So it can show you how much is the throughput on both the links when that speed test is kind of going on. Hopefully it is going on. It has not, yeah, it's
There we go.
still going on. It's considered as a bulk application leveraging both the links. At the same time, you can go to remote diagnostic. You can check the active flows. And then in the active flows, it will show you that it is a bulk application. Speed test has been recognized using the DPI engine also. And that we can
But
verify.
while you're doing that speed test, our Zoom call is still behaving correctly. It's not saturating the entire link.
It's doing okay. There were a couple fragments that happened while the speed test was happening.
No, that's where the quality of service comes to play. It should not happen that the bulk application, if you're doing a bulk download, that it takes away all the bandwidth and that gives no bandwidth to the real-time application, in this case, Zoom application out here. So if we want to see all the application, that's where it will also show me a speed test out here, which is considered as a bulk or a file sharing application out here. So speed test, it will leverage both the circuits out there. And do that again. We can run it again.
I'm assuming you can set up a rule to say if somebody in your office decides to do constant speed tests, that you can actually kind of stop that at the edge from happening, correct?
Yes, we can kind of do that through the business policies also. Or you can say that even if, let's say, when the speed test is going to happen, or if people are going to play Netflix or ESPN Sports, let's say on Friday, then that traffic should not go over the SD-WAN overlay tunnel. It should go directly to the internet. You could do that also. So that way you are not kind of competing against the bandwidth on that SD-WAN overlay tunnel. So you can do that also. The last one is this quality of service out here. Like I mentioned, not a single application should take over all the available bandwidth on that SD-WAN overlay tunnel. So we have a 3x3 matrix where we take the priority, application priority, high, medium, or low, and then the service class, which is real-time, transactional, and bulk like box.com or speed test, which we performed. Real-time is like Zoom application. So if a Zoom application, which is a high priority and a real-time, then it will get 35% of the total bandwidth, the aggregated bandwidth. So if aggregated bandwidth is 100 meg, which is upload plus download, then 35% is guaranteed for a real-time and a high priority application. If it's a bulk application, like I mentioned, it's a low priority like this download, then it will get 1%. But then
does this happen all of the time, or just when there's contention on the link?
No, when this contention happens. So if, let's say, I don't have any real-time application, only the bulk application is, then all the available bandwidth is given to the bulk application, okay. Let's say to speed test or box.com download. But the moment the traffic is seen for either a real-time or a transactional application, then this is what is guaranteed. These are what are guaranteed for these applications. Right. That's where the quality of service really works out. And this is for both, public or private circuits also. And if you remember, on the private circuit on the MPLS, we have those DHCP values given by the service provider. So we retain that DHCP value. So it's up to the enterprise either to leverage that DHCP value or override that DHCP value, rewrite it, and send it over the SD-WAN overlay tunnel. So both are possible. And I think that's where that application performance episode comes to play out here, is where, continuous monitoring, that's what you need to remember. Link steering and on-demand remediation happens in a sub-second per packet fashion. That's the key out here. And that's what is kind of defined out here in this bullet point. Continuous monitoring, dynamic application steering, on-demand remediation, and then the quality of service. Again, there are smart defaults defined in. You don't have to define each and every policy for all those 3,000 plus different applications. Smart defaults like bulk application, like I mentioned. The moment the traffic seen for a bulk application, it will aggregate all the circuits. If it's a real-time application, and if it's seeing some latency jitter packet loss, then it will replicate the packets. It will break the flow into packets. It will leverage all the circuits. Your application traffic on those packets will leverage all the links. And then on the other end, it will kind of constitute that flow and that session, and then it will send it to the destination. So sub-second protection against blackout and brownout condition. And this happens between edges and the hub, edges and the edges, or edges or the gateway. And then the DPI engine. That's what is DMPO all about, dynamic multipath optimization.
Thanks, Rohan. I think kind of key thing in this whole SD-WAN for me is that there is a centralized policy-based management for all of this. That although you can go through and override in places, the vast majority of your configuration is going to be based on these central policies, and that there's a whole lot of sensible defaults in there in the policies, so you're not starting with a toolkit to assemble together these policies, that you can actually reuse what's already there. Well, thank you, Rohan, for walking us through some of the more advanced features in the VMware SD-WAN solution. We will have one more episode with some even more advanced features that you might wish to use with the solution. So stay tuned for more videos around the SD-WAN solution from VMware and more Build Day TV episodes. Have a great day.